Good day and welcome back for the fifth and final installment of this section covering arc length, curvature, and more. So in the previous few videos, we've introduced all of the concepts, new formulas, ideas. We've seen a little bit of practice. And this is a point where I would really turn it over to you all. This worksheet along with solutions are posted on Canvas as usual. Hopefully you've had a chance to look at it and work through um, as much as you can. And I'll note that for any of these times where we have worksheets and I ask you to work through them, it's to make the learning as beneficial as possible for you. There is no better way to learn the material than to kind of roll up our sleeves and maybe even struggle through it a bit on our own. So in this video, what I'd like to do is focus in specifically on parts A and B because these are some fairly, we'll say, computational technical portions of the problem. But once you correctly have T and N, the other four parts should follow somewhat more quickly from those kind of building block formulas that we develop. All right, so let's go ahead and dive right in. To find the unit tangent vector, once again, this is a nice methodical approach. We need to know r prime and its magnitude. From above, just to kind of cut and paste it down to make our work as easy to follow as possible, we have r of t, and in order to calculate r prime, we need to differentiate this component by component. So 1 for the first component, and whether we're differentiating the second or the third component, both of these require kind of the chain rule in a sense. We differentiate this outside function, so the 3/2 comes down front, and we'd be left with a 1/2 t plus 1 to the 1/2 power, and then the chain rule tells us we multiply by the derivative of the inside function. In this case, you're really multiplying just by 1, but I'm going to write it down just so that we see the difference in the next part. So similarly, the 3/2 comes down front, the new power is 1/2, and by the chain rule, we multiply by the derivative of that inside function. So this is where we introduce a negative sign. We also need the magnitude of r prime. So we would take the square root and we'd have the sum of the components squared. So 1 squared plus we would have the quantity 1/2 times the square root of t plus 1 squared. So that would be 1/4 t plus 1. And note that if there's any confusion here, t plus 1 to the 1/2 is really the square root of t plus 1. And then similarly with the third term, you would have 1/4, and then we would have this times 1 minus t, and when we square, that negative 1 just vanishes. And note in the second and third term, we do get quite a bit of cancellations in a nice way, because remember this 1/4 needs to distribute. We would have a 1/4 times t minus 1/4 times t. So this all simplifies down to be the square root of 1 plus a quarter plus a quarter. So it would be the square root of 3/2. So we now have our unit tangent vector. Let's create just a little bit more space. So the unit tangent vector is r prime divided by its magnitude. So r prime is 1 1/2 t plus 1 to the 1/2 minus 1/2 1 minus t to the 1/2. And we divide this by the square root of 3/2. And remember, dividing by a fraction like root 3 over root 2 is equivalent to multiplying by its reciprocal. So we could write this as the square root of 2/3 times the vector that we've computed. So this completes the steps for part A. we have the unit tangent vector. Up next, and equally or even more fun, is finding the unit normal vector. So in order to find the unit normal vector, we need those two key ingredients, t prime and its magnitude. So let's go ahead and just compute this out. Remember, very methodical, small incremental step, one at a time. So in terms of differentiating, that constant can hang around out front, and then we differentiate each term individually. In either case, we are once again going to use a chain rule. So we think the 1/2 comes down front. The new power is going to be 1 less than 1/2. So we would have 1/4 times t plus 1 to the minus 1/2. And once again, there is a chain rule going on, but you're multiplying by 1. In the third component, similarly, you have a minus 1/2 times 1/2, so minus 1/4. 1 minus t now to the minus 1/2 power. And by the chain rule, you have a minus 1. And note the minus, a minus makes that a plus. And this is a part where I'm going to rewrite this just a little bit to make our algebra as simple as possible. So I'm going to keep the square root of 2/3 hanging around out front. Note, raising a quantity to the minus 1/2 power is equivalent to dividing by that quantity raised to the 1/2 power, or dividing by its square root. And just to make our kind of work as nice as possible, I'm going to go ahead and get a common denominator in the second and third components just to make the magnitude of t prime work out a bit more smoothly, but you certainly do not have to do this. You can kind of do the algebra as you go along. Note that the square root of 1 plus t times the square root of 1 minus t is the square root of 1 plus t times 1 minus t, which is a difference of squares. So the square root of 1 minus t quantity squared. So what I'm going to go ahead and do, and I guess I have plenty of space, I'll rewrite a bit, is in that middle component, I'm going to multiply by 1 as the square root of 1 minus t over the square root of 1 minus t. And in the third component, I'm going to multiply by the square root of 1 plus t over the square root of 1 plus t. And I'm doing that purely, once again, to create a common denominator to make the magnitude computation as simple as it can be. And I'm also going to pull a 1/4 out front. So note you have a 1/4 in the second and the third component. We can go ahead and pull that out front because the first component is 0. So if we put the 1/4 back in, that 0 is still unchanged. So our second component now has become the square root of 1 minus t over the square root of 1 minus t squared. And the third component is the square root of 1 plus t over the square root of 1 minus t squared. And as claimed, this is a pretty technical problem computationally. Just lots of little steps. But if you can kind of follow through and push through this step by step, that's a really good sign that you would be prepared for any problem we were to throw at you, say on a future homework or exam type of assignment. Okay, so in order to find the unit normal vector, we don't want to lose sight of what we're doing, we need to find now the magnitude of t prime, but hopefully our above algebra work is going to make this easier. So remember, the magnitude of a constant times a vector. We would take the absolute value of that constant, which note for the absolute value of that constant, it's positive, so it's just the constant. And then we would multiply it by the square root of the sum of the components squared. So we don't have to write it, but 0 squared. And note, when you square both of these second and third components, it works out as basically as well as we could possibly hope. The square roots just go away. So you'd have 1 minus t over 1 minus t squared plus 1 plus t over 1 minus t squared. So we have this constant hanging around out front. Underneath the square root, we have a common denominator. And note when you combine their numerators, 1 minus t plus 1 plus t. So the minus t's cancel, and we end up with simply a 2. And I'm going to simplify it just one more step. So you have 1/4 times the square root of 2/3 times the square root of 2 over the square root of 1 minus t squared. And we now have the kind of key ingredients that we need to write down the unit normal vector. So the unit normal vector is t prime divided by its magnitude. And I know this is highly computational and probably, I was going to say a bit, but it's extremely dry. So I appreciate it if you've stuck with me to this point. So we have t prime would be 1/4 square root 2/3, and kind of cut and paste that vector down. So square root 1 minus t over square root 1 minus t squared, and square root 1 plus t over the square root 1 minus t squared. And lastly, we divide all of this by that formula directly above, the magnitude of t prime. And believe it or not, things are actually looking quite good at this point. So let's just cancel what we can cancel. So 1/4 square root 2 over 3, square root 2 over 3. Also, note that this square root of 1 minus t squared, which is the denominator in each case, can also be canceled. And what we are left with for this normal vector is you have a 1 over root 2, where that 1 over root 2 corresponds to the two circled quantities, multiplied by the vector 0, square root 1 minus t, square root 1 plus t. And this is our formula for the unit normal. So it looks as though, at least for a while, that the computations are going to be a complete, utter, disaster. But lo and behold, if we push through this algebra and hang in there long enough, things work out in a very reasonable fashion. Now, note this is just parts A and B. There are a few more parts to go. But with T and N determined, going on from there to find things like, say, the unit binormal, the curvature, normal oscillating planes, should follow fairly quickly. So I recommend working through those details, check with the solutions posted on Canvas. If you have questions, let me know. Also, work suggested problems from this section, and feel free to drop me an email or stop by those virtual office hours. So stay tuned and take care.